Okay, so good afternoon. Our topic will be heat transfer. It is part of your industrial engineering. Okay? Industrial engineering tapos ng power plant. So pipe, EIPE pagdating ng inyong board exam. So heat transfer. It comes after ng inyong calorimetry and then yung inyong heat thermodynamics. Okay? Sabi nila, yung heat transfer daw, isa yan sa pinakamahirap ng mechanical engineering fundamental. But to tell you frankly, hindi yan ang pinakamahirap. Okay? What makes it complicated is that ang dami mo kasing pagdadaanan na calculation. Okay? Lalo na kung meron kang marami kang conversion of units. Ang kagandahan kasi dito sa heat transfer, ang formula mo ay ilan lang. Okay? And then kung meron kang drawing, sa lahat nga ng sinasabi ko sa akin mga klase pagdating ng ah, may mga diagrams and drawing, mas maganda i-drawing mo muna para maintindihan mo yung buong process. Now, pagdating naman ng heat transfer, ang pinag-uusapan lang naman natin dito solely is heat. Okay? Saan nanggaling yung heat na yun? I don't know, sir. Okay? From a body that contains heat or exerts heat. Okay? Yung heat na yon magta-transfer yan into different mediums. Solid, liquid, even gas. Okay? So, marami tayong questions dito na i-prepare. I won't go to the fundamentals, pero ituturo ko sa inyo kung paano ba natin masosolve yung mga very complicated problems pagdating ng heat transfer. Since nakarating kayo ng point na to, kung saan i-review ko na lang kayo. Okay? So, the notes will come out after this discussion and after 3 problems, I will have a break. Okay? So, ilang problems to? I have here prepared 17 problems. That's all about heat transfer and heat exchangers. Doon lang tayo iikot. So, our keynotes, kailangan alamin mo yung conduction, convection, and radiation. Okay? Ano ba yung mga parts na yun, sir? Conduction, uh, convection, convection to composite walls, they transfer from fluid to pipes. Okay? Mas maganda kasi pag-usapan natin siya involving different problems. Okay? So let us go with problem number 1. Pero bago pala yon, i-discuss ko muna yung mga general constants na ginagamit natin pagdating dito. Number 1, for R bar, universal gas constant. This is SI unit, 8.3143. Tandaan nyo ito. Paulit-ulit nyo nang gagamitin yan hanggang chimneys. And then this one. Okay? Ito kahit hindi na. Okay? Kahit di na to. Ito lang dalawa mahalaga dyan. And then ito, kailangan pa bang tandaan to? Not necessarily. Not necessarily. This one, this is the Stefan Boltzmann. Stefan. Okay? Stefan ata. Stefan Boltzmann. Boltzmann constant. Double N ata yan. Constant. For radiation to, okay? Now, the solar constant this is the heat transfer as measured, average. Pag sinabing the heat came from the sun, so this is constant kapag radiation. Considering the effects of the solar heat, okay, ganun yung mga problems na yan. The radius of the earth, yung mga exit velocity, and then human heat kapag nagde-design ka na pagdating ng aircon naman. This is the average human heat load. Ayan, 225 BTU per hour. And then for the CP ng water, that is also equal to CV. Kapag naman nangyari is kapag alam ko pag English units, that is 1. And then LF, latent heat of fusion. Andito na. Pero ang gagamitin kasi natin to, more or less, more on more on refrigeration and air conditioning. Not necessarily gagamitin natin siya. And then this is for fluid mechanics. Yung ice, okay, as is. Okay, sa air, 1.4. CP is 1, 0.24. Tapos 0.7186. Lagi na to kailangan kabisado niyan. And then, much for that, wala na tayong kailangan kabisaduhin pa dito. Another one, kapag sinabing flow, kailangan ito. Okay? 0.880 BTU per hour feet squared multiplied to degree Fahrenheit. Ito mahirap dito kasi ang dami diyan sa conductance mo, marami kang units na kailangan mong tandaan. Okay, 1 board feet. Ang 1 board feet, ibig sabihin 1 board feet kapag sinabing, "Sir, pabili ako ng 1 board feet plank." Okay, ito yung measurement niya. Length, width, and thickness. Okay, yan yung 1 board feet. Now, ito na yung mga formula. Gamitin natin sila para hindi natin sila malilimutan. Okay? Ayan, hindi ko na i-discuss yan. So, let us go with problem number 1. Problem number 1. Calculate the energy transfer in watt per meter squared across a 6-inch wall of fire brick with a temperature difference across the wall of 55 degrees Celsius. The thermal conductivity of the fire brick is 0.65 BTU per hour feet. Tama ba to? The feet degree Fahrenheit at the temperature interest. Ayan. So, what better way para maian natin siya ma-solve is to draw it. Okay? Pagdating po ng heat transfer, the heat that came in contact with the medium will be the same heat after mag-pass through dun sa medium na yon. Okay? So, for conduction, i-drawing natin yung figure. Let us draw the figure. Ayan. So, if this is your wall of a fire brick, okay, magpa-pass through daw po dito yung iyong heat. Ano ba ang magandang sa heat? Ito na lang, blue. So, yung heat mo na papasok dito sa iyong fire brick, which is Q, will be the same heat na lalabas dyan. Okay. Ano lang po nagbago? Okay. Ang magbabago dito is simply the temperature. The temperature on the hot side. And then the temperature on the low side. Hindi. O, tama. The heat source. Temperature hot, temperature low. Now, calculate the energy transfer, the same transfer, okay, across 6 inches. Okay? Meron ka daw 6 inch dyan. Meron kang 6 inch na thickness. The thermal conductivity of the fire brick. Sir, ano po ba yung conductivity? The thermal conductivity is commonly, okay, denoted as letter K. Yan. Letter K. Now, sir, conduction through walls. Okay? The conduction through walls, it is given by the formula. Q will be equal to K tapos yung area nung iyong surface, okay, delta T divided by X. Yan. Commonly, itong surface na to, kung i-extract mo yan, okay, tanggalin natin. Okay. This one. Kung i-extend mo yan, papunta ron, okay, itong wall na to, sir, is meron po yang, okay, surface area. Itong wall na nag-pass through ka. And that is commonly measured, yung area niyan. Depende. Depende po. Ano po ba yung area ang tinutukoy natin dyan? The surface area, it's either kung cylindrical yung face niya, kung rectangular yung face niya, or simply a square yung face. Okay. Now, ang hinahanap natin dito is the energy transfer, which is Q. Okay? Anong binigay sa'yo dyan? Okay. Wala pong binigay dito, sir. Pero meron kang binigay na K, meron kang binigay na delta T. So, the delta T here will be yung 55 degree Celsius. Now, what is our dilemma here? Tignan nyo. Again, yung turo ko sa inyo, kapag mostly, okay, mostly ang hinahanap dyan, or most of the units there are commonly given sa iisang majority is in SI, di SI ang gawin mo. Saka ka na lang mag-transfer or mag-translate or mag-convert pagkatapos mo mag-compute. Okay? Now, anong hinahanap niya dyan? The heat transfer. Ano po ba ang unit ng heat transfer? Watts. Anong pong unit ng K? Okay. Ang unit ng K is simply pwedeng BTU. Okay? Tignan mo dyan, BTU per hour, feet. Okay? Tapos, degree Fahrenheit. Or simply, kilojoule per hour, feet, feet tuloy, meter, degree Celsius. Pwede yan. Okay? Or simply, itong K, pwedeng kilojoule or Q or watt. Watt meter per degree Celsius. Ano po naman itong delta T? Okay? Delta T is the change in temperature either degree Kelvin, degree Celsius, degree Fahrenheit, or degree Rankine. Yung X po, it's either in inches or in millimeters. Okay. So, meron na tayong formula for conduction through walls. Q will be equal to K A delta T over X. Okay. Let us box that one. Now, going here. Ang hinahanap po natin is, on your problem, ano pong hinahanap natin? That is in Q over area. Ano ba unit niyan? That is in watt per meter squared. Okay? Ito yung hinahanap natin. So, simply, pwede na natin tong simplify. Okay? A, Q over A equal to K delta T over X. Okay? Ito yung hinahanap natin. So, hindi naman nagbigay ng area. So, proceed. Q over A will be equal to K. Sir, ano pong binigay mong K dyan? Ayun, 0.65. 0.65 BTU per, anong unit? R, feet, degree Fahrenheit. Okay? Delta T. Oh, di ba kapag delta T? Paano yan? Tignan nyo. Pag delta T, gusto mong gawin yung degree Celsius, baliktad na to. Pag, paano mag-denote, sir, ng commonly, mapapansin nyo sa problem. Kapag delta, degree Celsius, that is simply hindi pa yan change in temperature. Okay? Pag naging change in temperature, Celsius degree to degree Fahrenheit. O Fahrenheit degree. Paano po isosolve yan? Okay. Pag equal ito sa, multiply mo na lang ng 9 over 5. Okay. Kahit hindi na 9 over 5, 1.8. Multiply mo yung Celsius degree. Okay? Paano naman po kapag degree Fahrenheit to Celsius degree? O di equal mo yung Celsius degree Fahrenheit divide mo ng 1.8. O, ganun lang. So, 55 ang naging change natin dyan. 55 times 9 over 5 or 1.8. 1.8. 9 over 5 or 1.8 degree Fahrenheit. Ngayon, ang problema natin dito, yung unit cancellation. Watt per, yun, meter squared ang problema. Okay, tignan nyo yung magiging change natin dito. That is 6 inch. Okay, kailangan makancel muna natin yung feet. Ay, hindi pala. Kailangan maging feet squared siya. So, this is, pag minultiply mo, bale 1 feet over 12 inch. Okay. Set aside mo muna dito. Q over A, tignan mo yung mga units. 0.65, yan nagpahirap dyan, yung unit cancellation. Okay. BTU, isolate mo na, okay? 0.65, yung BTU, per hour, feet, tapos yung degree Fahrenheit. Ngayon, yung BTU, i-convert mo dapat yan ng kilojoule. So, 1.055 kilojoules per 1 BTU. Okay. Tapos, i-multiply mo na agad yan ng 55 times 1.8. 1.8 times 55 degree Fahrenheit. To cancel yung degree Fahrenheit. Tingnan mo, makakancel na dito yung inches, magiging feet squared. Okay. So, this is 6 over 12 feet. Magiging feet squared na, di ba? In order for you to cancel yung feet squared, mag-multiply ka dito ng 3.28 square feet squared, 1 meter squared. Ayan yung cancellation ng units niya. Ngayon mapapansin mo naka-R. O di multiply mo agad ng ano. Naka-R yan, di ba? 36 seconds. 3,600 seconds. 1 hour. Tignan mo, unit cancellation. Mahaba lang talaga. Okay? Pero matuto ka dapat sa papel mo na lang i-translate yan. Sa papel ka na lang mag-convert. So, BTU, cancel natin. Cancel to. Yung feet, tapos yung feet, cancel na dito. Yung degree Fahrenheit, degree Fahrenheit. Yung kilojoule, tsaka to, bilugan mo. This will become, cancel to. Cancel to. Matitira yung seconds. Okay? Tsaka meter squared. Ngayon, ano nangyari? Kilojoule seconds. Okay? That will be kilowatt. Kilowatt pa rin. Ang hinahanap dyan is watts. O, di wag ganito dito. Okay? 1,000 watts divided by 1 kilowatt. Okay, pwede ka na mag-solve. Okay? So, isang pindutan po sa calculator. Diyan ka na sa calculator magpipindot niyan. So, $1.8 times 55 times 1.0. Hindi, kahit di na pala. 1055 na lang. Kasi may 1,000 eh. Okay, times 0.65 times 3.28 squared. Divide mo na ng 6 over 12. Bali 1/2 times 3,600. The answer will be in watt per meter squared. That is 405. Tama ba yung naging sagot natin? Okay, this is, okay, tayo. Q over A will be equal to, Q over A will be equal to 405.77 watt per meter squared. Okay? What made it complicated? Yung sinasabi ko, yung unit cancellation. Parati ka mag-unit cancellation pagdating ng dulo. Okay? Nailista mo na lahat. Wag ka muna mag-unit cancellation pagdating ng unahan. Next problem. That is for the conduction. For number 2, a cold storage compartment is 4.5 meters long and 4 meters wide by, okay, by 4.5 by 2.5 meters high. 4 walls, hindi 4 whales yan. 4 walls, ceiling and floor are covered to a thickness of 150 millimeters with insulating material, which has a coefficient of thermal conductivity of 5.8 times 10 to the negative 2 dapat to. 5.8 times 10 to the negative 2 watt per meter degree Kelvin. Ayan. Calculate the quantity of heat in kilojoule leaking through the wall insulation per hour. When the outside and inside phase temperatures of the material is, uh, that is number, tama ba to number? Ayan. The outside temperatures of the material. So, kailangan mo palang i-drawing yung cold storage room dito. Okay, drawing ko muna siya. Blue naman. Gusto ko blue eh. So, this is the cold storage room. Gumagaling na ako sa pagdodrawing sa notepad. Okay? Pupunta rin kayo pag kayo nag-heat load calculation. Kailangan per wall, kukunin niyo yung heat transfer niya. Okay. Diba? Engineer na engineer sa pagdodrawing. Okay? Ayan. From there, the quantity of heat, alamin natin. So, dito, meron kang temperature na when the outside and inside phase. Sa outside, 15 degrees Celsius. Okay? Sa inside phase, sa loob, meron kang negative 3 degrees Celsius. Ngayon, saan po ba papunta yung init? From malamig to mainit or from mainit to malamig? So, your temperature, yung heat, will go from the hot side to the cold side. So, this is the T high. This is the T low. Now, ang hinahanap natin dyan is the quantity of heat. Ngayon, if this is a parallelepiped, excuse me, meron kang 4.5 meters long, meron kang 2.5 meters high, and then meron kang 4 meters wide. Aalamin mo yung surface area. Now, going back to your solid geometry, the surface area of a parallelepiped or a prism is simply equal to twice nung length multiplied to the width plus width times height, okay, plus yung length and then height. This is for the parallelepiped or the prism. Now, pare-pareho lang naman yung conductivity ng wall mo as stated. So, meron kang thickness per wall na 150 millimeter. Okay? So, X is equal to 150 millimeter. Yan. So, conduction through walls, hindi pa composite walls. Okay? The formula is Q will be equal to the area or the total surface area multiplied to K. Okay? Multiplied to TH minus T low. Yan. X. O ngayon, sir, para po madali natin matandaan, hindi ko po alam yung formula to nung conduction through walls eh. O ganito, para matandaan nyo. Sir, for the formula, ang gagawin mo dyan, kapag nainitan ka, anong kailangan mo? Di ba kailangan mo ng aircon? Ngayon, sa init, sobrang init, wala kang aircon, nabore ka. Anong kailangan mo ngayon? Anong kailangan mo ngayon? Di ba kailangan mo ka-text? Tignan mo ah. Paano naging ka-text? Kapag nainitan ka, sir, kailangan mo ng ano? Ka-text. Okay? Di ba? Ka-text. Yun. So, ito yung mnemonic niya para hindi mo malimutan yung conduction through walls. Now, let us solve the problem. So, Q ang hinahanap. Yung area natin. Area, pwede nating isolve. Pero kung mas gusto ko kasi, nagsusolve ako ng isahan na lang. Now, for Q, the area of the surface, okay, will be 2. Pagpare-parehasin natin. So, this is the length, this is the width, this is the height. Unahin natin, the length and the width. 4.5 multiplied to 4. Okay? 4.5 multiplied to 4. 4.5 multiplied to 4. Tapos, plus 4.5 multiplied to 2.5 plus 4 multiplied to 2.5. Now, what will be the unit? Ang unit po niyan, sir, is meter squared. Meron na tayong A. Ano naman, yung K naman, multiply natin. So, what is the K? That is 5.8 times 10 to the negative 2. 5.8 times 10 to the negative 2. Anong unit niya, sir? Watt per meter degree Kelvin. Hmm. So, the temperature difference na lang. Anong temperature difference niya, sir? 15 and negative 3. So, 15 minus, tapos naka-negative yung 3, minus 3. Yan. So, maging positive itong dalawa. Okay? Positive. Anong unit ito, sir? Degree Kelvin. Kasi change in temperature naman na yan eh. Okay, yan na. Divide natin ng X. Okay, ano yung X niya? The X will be 150 millimeters. Naka-meters to lahat. So, 150 divided by 1,000 mo na agad para maging meter. So, meter. Cancel all the same units. Yung meter squared, yung meter, yung Kelvin, yung Kelvin. Ang lumabas is watts. So, let us calculate. Isa na lang 2. 4.5 times 4.5 times 2.5 plus 4 times 2.5 plus 4 times 4.5. And then multiplied to 5.8 times 10 to the negative 2 multiplied to 18. Additive na yan. So, 150 divided by 1,000. 1,000. Okay, the answer is okay. Ang kailangan natin dito, naka-watt. Anong unit ang hinahanap, sir? Tignan nga natin. Okay. Kilojoule. So, in kilojoules. This is in watts. Okay. May binigay pa ba dito? Per hour. Ayun, per hour. Insulation per hour. Okay, kilojoules. So, this is 546.36. Q. 546.36. Watts times mo to. 1 watt is equal to 3,600. 3,600 ulit. 1,000 joule per second times. Okay? Kilojoule ang hinahanap natin. 1,000 joule. Tapos 1 kilojoule. Multiplied to 3,600 seconds. 1 hour. So, cancel all the same units. Yung watts, yung joule, yung seconds, yung seconds. Ang natira is hour and then kilojoule. Okay? Now, Q will be, so cancel mo na yung 1,000, multiply mo na lang to ng 3,600. Oy, mali pala. 1 joule per second. Tama naman. To 1 kilojoule, 1 joule per second. Mali pala, hindi pala to 1,000. Ayun, 1 lang to. Okay, 1 lang yan. So, yan. Diniretso ko eh. Okay? Divided by 1,000. Hoy, namatay. Okay? Naghang siya. Ayun. So, that is 546.36 multiplied to 3,600 divided by 1,000. The answer is 1966. 1966.896 kilojoule per hour. That is the heat transfer through the walls. Okay? Another problem, number 3. What is the number 3 problem? In one insulated wall of a cold storage compartment is 8 meters long and then 2.5 meters high. Consists of an outer steel plate 18 millimeters thick. Meron siya outer steel plate. An inner wood wall is 22.5 millimeter thick and the steel and wood are 90 millimeters apart. Okay? To form a cavity which is filled with cork. Yun. Steel and wood. From the cavity which is filled with cork. Ayan. If the temperature drop across the extreme faces of the composite wall is 15 degrees Celsius, calculate the temperature drop across the thickness of the cork. Take the coefficients of conductivity for steel, cork, and wood as 45, 0.45, and 0.18 watt per meter degree Kelvin, respectively. Okay? Ano daw yung magiging Q? Now, this is, we're talking about composite walls. Okay? Tingnan nyo ito. Sa composite wall, okay, the same lang yan ng, the same lang yan ng conduction. Okay? Ang kaibahan lang, magkakaiba ka ng thickness dito, iba-ibang thickness, and then iba-iba rin ng what? Iba-iba rin ng thermal conductivity. Now, i-drawing muna natin yung surface. Better draw the surfaces. You draw the surfaces. Hatiin natin sila. Sa first one, an outer steel plate. Okay? The inner wood. Ito yung steel. Okay? Ito yung wood. And then dito yung cork. Lagyan natin. This is the steel. This is the wood. This is the cork. Now, magpa-pass through daw dyan sa yung wall, yung Q. Okay? Now, this is composite wall. Meron tayong X1, meron tayong X2, meron tayong X3. Mas maganda din na drawing mo para hindi ka nalilito. Okay? K1, K2, K3. Okay? Now, sir, medyo mahirap para sa akin to solve that. Okay? Pagpalagay natin, this is outer, this is inner. Okay? Now, yung heat transfer from here up to here will be constant. The Q is constant throughout the process. Now, sir, medyo nagugulan pa rin ako. Pero let me tell you this, okay? Kahit gaano karami yan, the best way for you to do that is to list down muna yung pinaka-formula. Oh, sir, pag nainitan ako, anong kailangan ko? Nainitan na ako, nabore pa ako, di ka text. Okay? Kailangan mo ng ka-text. Sir, iba-iba yan. Ang dami niyan eh. Okay? Pwede na to. Okay? Suffice na yan. Tandaan mo na itong dalawang to, okay? Depende yan kung gaano karami. Ngayon, di ba, meron kang total dyan, RT. Okay? The total resistance. Okay? Yung conductivity kasi yan, the resistance to heat. Di ba? Resistance. Okay? Pwede yung RT. Okay? Napatandaan nyo ba yung inyong mga resistors? Ngayon, pag parallel sila, since this is parallel, hindi naman yan series. Kapag parallel po yan, ang mangyayari, sir, is that, tandaan nyo, the X sub 1 over K sub 1 plus x sub 2 over k sub 2 plus x sub 3 over k sub 3 and so on. Okay? Oh, and so on. Yan yung ating gagamitin. Sir, mas maganda kasi part by part tayo magso-solve. Hindi tayo magso-solve na magkakaparehas at magkakasunod para hindi tayo nalilito. Since tatatlo ito, Q, ilista mo. Oh, Q out is equal to QI equal to, pag walay mo to, A delta T over resistance. Okay, RT. Okay? Where your RT is here. Oh, first lang sir. Okay, isolve ko muna si RT. Okay? RT muna. Wag mo na ipasok dito sabay-sabay para hindi ka nalilito. Oh, si x sub 1, what is x sub 1? Oh, naka-ano siya? Naka-millimeter. O kailangan gawin mo ng watt. Gawin mo na kagad siyang meter. So, inner wood steel plate is 18. Lagay mo dito 18 mm. Tapos nakalagay dyan is 25. Mhm. May sinabi dito eh. The steel and wood are 90 millimeter apart to form a cavity which is filled with cork. So, ito daw, from here up to here is 90 millimeters, yung buo. Okay? From here up to here, 90 millimeters. Ang problema, mali ako ng tingin dito kanina. Nasa gitna dapat yung cork. Bakit mo nasabi yun, sir? Tignan niyo sa problem. Ayan. An inner wood, okay, wall, meron kang 25 millimeter thick, and then the steel and wood are 90 millimeters apart. So, steel and wood, 90 millimeters apart. Hindi pala total. Okay? Yung dito lang, yung sa cork yan, 90 millimeters. Mali na naman ako naintindi. Okay? Ayan. This is 90 millimeters. Tapos, ito, 22.5. Okay? Yan. Tama na to. So, pwede na nating samahan dito sa resistance, total resistance. So, x sub 1, ano yung thickness niya? I think that is 0.08. Sir, saan nakuha yan? O, di meters. Tignan nyo dito. O, 18. 0.018. Hindi. Sabayin na natin. 18 divided by 1,000. Millimeters eh. O, di meter. Tapos yung ano, yung kanyang K, which is steel, that is 45. 45 watt per meter degree Kelvin. Plus, yung sumunod, 90. 90 over 1,000. Meters na agad. Kasi hindi kakayanin sa calculator ng sabay-sabay. 0.045 watt per meter degree Kelvin plus 25. Ayun. 22.5. 22.5 divide by 1,000 meter. Tapos, yung kanyang thermal conductivity, 0.18 watt per meter degree Kelvin. Ayan. Tignan natin yung units niya. So, ito aakyat. Okay? Itong watt nasa baba. Yung Kelvin aakyat. Okay? May maka-cancel bang unit? Wala. So, pwede mo na isolve yan. Okay? RT. Ayan. Is equal to. Lagay mo muna dito, set aside. And then, pasok mo na dito sa calculation mo na QO is equal to QI equal to yung area, excuse me, the area is area delta T. Pasok ko na pala dito. Area is 8 meters tapos 2.5 meters. 8 by 2.5. 8 by 2.5 meters squared. Yung delta T mo, tignan mo dyan, 15 degrees Celsius. O, di 1560. 15 Celsius degree over RT. Sir, turuan ko kayo ng ng technique sa calculator. Hawakan niyo yung calculators niyo. Okay, iso-solve ko muna ito tapos susunod ko itong Q and then yung A. Now, yung RT mo, gawin mo 'tong di ata sapat. Okay? A, B, C, D, E. Mhm. A, B, C, D. Oh, pwede naman. Pwede naman. Gawin ko 'tong X, gawin ko itong Y. Baguhin natin ang kulay. I'll do this as X and then gawin ko 'tong Y. Okay? This will become A, B, C, D, and E. Ayan. Para ma-solve natin siya. So, alpha, X, alpha equal to, tignan yung gagawin ko So, this will become alpha A over 45. Para mabilisan lang. Okay? Alpha B 0.045 plus alpha C over 0.18. Sir, ba't mo ginagawa yan para mabilis tayo mag-calculate? Okay, yan. Tapos yung Y na kagad. Alpha Y, alpha equal to, yung D, alpha D, alpha E, alpha X. Oh, you press the calculate. Okay? Calc. A. Ano yung value ni A? 18 over 1,000. O, dito. 18 over 1,000. O, next one, yung B. 90 divided by 1,000. Yung C. 22.5 divided by 1,000. O, tatanungin naman yung D. 8 by 2.5. O, tatanungin yung E. That is 15. Isang pindutan. Nakuha mo agad yung RT. That is, the RT is 2.1254. Anong unit niyan, sir? Meter squared per meter squared degree Kelvin over watt. Ilalagay mo dito sa ilalim. Ang lalabas diyan naka-watts na. Okay. And then, the answer will be 141.1499 watts. Okay? Ganun lang kadali pag heat transfer. So, kailangan part by part ka magso-solve. Hindi mo siya susunod-sunurin. Kasi, pag nagkamali ka isa dyan sa calculator mo, uulitin mo na naman yung kanyang input. Diba? So, I told you, and then I taught you yung pinakamabilis na paraan para makapag-compute ka. Okay? So, ayun lang. Hintayin mo lang yung final value nito, diba, sa 2 parts. And then, nakuha mo na. After makuha mo yung final. You don't have to stress yourself over things na nahihirapan ka. Okay? Let us take a break. So, ang hinahanap pala dito is temperature drop. So, let us continue. Yung temperature drop niya, that is Q. Hindi pa to final Q is equal to K sa composite wall, delta T times area over X. Yung total, okay? Sa cork lang, hinahanap yung sa cork. Tingnan natin yung problem. Ayun. Calculate the temperature drop across the thickness of the cork. Okay, basic yan. So, the temperature drop at the cork. O, di hanapin mo yung sa cork. O, meron ka na. Diba, all throughout the system, okay, Q is constant. O, hinahanap mo tong temperature drop. So, delta T. Delta T on the cork is equal to that is QC XC over KC A sa cork. QC. 141.1499 watts multiplied to 0.90 kasi that is na hindi 0.090 yung thickness ng cork, that is 90 over 1,000 meters. You multiply it with kc. Ano ba yung kanya sa cork? Ah, cork nasa gitna 0.045. 0.045 watt meter Kelvin, watt per meter Kelvin, multiplied to the 8 times 2.5 meters squared. Cancel all the same units. Yung watt, yung meter, meter squared, meter. Ang lalabas dito in delta C, delta T ng C is, okay, store natin kay A ito. Okay. Alpha A times 90 divided by 1,000. Then 0.045 times 8 times 2.5. The answer will be 14.11. 14.114 or 115 degrees Celsius. Ganun lang, yung mga pressure drop niya. Pag tinanong ka naman ng pressure drop nung isa, di gamitin mo yung K nung isa, okay? At saka yung thickness nung isa. Yun lang ang magbabago dyan. Ito, laging constant yung area and then yung constant din yung area nitong, constant din yung area. Constant din yung Q. Okay?